Well, hi there folks, welcome back to the last video of this Battleship web video series, this walkthrough. This is the final video. You've already got a Battleship game that works about 99% of the way. Little bugs here and there, but we're not going to worry too much about them. In this video, the final video, we're going to create the AI for the hard computer. I've left this one for its own bit because we're going to use a little bit of recursion. It's like a brand new thing for me, using a recursive function. I could have used a list. I could have used a for loop to try and determine all the specific cells next to the ship where a hit has taken place, and then branched out from there. I figured I would try a recursive recursion. I'm reading through the book of recursion by Al Swigart. It's called The Recursive Book of Recursion. I'm busy reading through that currently, and I thought I would give it a try with this video. I also want to get used to using recursive recursion because I want to give it a try with a Minesweeper game at some point. The way I got it to work on this one is going to make it quite fascinating. I'd like to give it a try and give a Minesweeper game a go the next time around we do another video series. Right now, let's go ahead and build our computer class, our hard computer. So here in our classes, under my class Easy Computer, I'm not going to do inheritance or anything like that because within one of the let's go ahead and try an inheritance. Hard computer, we're going to inherit from Easy Computer. Okay, we're not going to entirely inherit because we do need to have a couple of our own attributes. We don't need last turn, we don't need those, don't need those. So in our hard computer, we're inheriting from the easy computer. We're going to define init self, and then we're going to call super.init method. So we're going to inherit all the original stuff from the easy computer, all the attributes. And then we just want to add one more attribute. We're going to call it self.moves, which will be a list, an empty list. Fantastic. Okay, looking further into our hard computer. Okay, so now obviously we've inherited from the easy computer, which means we've also inherited the easy computer methods, the computer status method, the computer make attack, and the computer draw method. What we want to do is actually we want to override the make attack method, and because of that, the reason for this is inside this make attack method we're going to start using our recursive method. Here when there's a hit we need to make a recursive method call. Okay, so I'm going to go define my make attack self and game logic like was previously. Alright, so in this method we're going to go ahead, we're going to go with if length of my self.moves. Remember that empty list we created an attribute. So if the length is greater than 0, right, which means that there's items in my moves list, well, now we're going to do a random move. So computer, what did we call it? Comp turn timer. So our comp turn timer is going to be equal to Pygame dot time get ticks. Right? Comp turn timer is Pygame dot time dot get ticks. If comp turn timer minus my regular turn timer is greater than or equal to 2000, we have it as, right? Am I right? 3000. Okay, let's make it 3000. 3000. Okay. Valid choice is equal to false. Right, while not valid choice While not valid choice, So on row X, we want to choose random.randint 0 and 9, and then row Y, we want to choose random.randint 0 and 9. Right. If game logic row X row Y is equal to space or game logic row X row Y is equal to O. Okay, valid choice will then be equal to true. So we break out of this while loop. Once you break out of the while loop, now do it. If and logic row X row Y is equal to O. Well, the first thing we need to do is we're going to tokens, but append tokens, right? And in my easy function, in my easy class make attack, we've already got this section set up. So I'm actually just going to take this and copy paste it, if you don't mind, just to save us a bit of time. From there, we go to X and O. Okay. So row X, and there's going to be row Y. Row Y. Okay. Row Y. Same thing here on this line, we'll do row Y. Row Y. Okay, so as I mentioned before, my make attack is going to be basically the exact same as on my easy computer. The only difference is over here, if it has been a ship hit, we then need to call our new method that we're going to create shortly. Self.generate moves. Okay, and we're going to pass to it our row X, row Y, and we're going to pass to it the grid, game logic grid. Okay, so that's the first change that we make to this make attack, and then the second change we make to it is, in line with our if len self.moves is equal to 0. I'm going to say elif len self.moves is greater than 0. So else if the self.moves is greater than 0, say compute comp turn timer is equal to pygame.time.get ticks. Sorry, I just noticed how it was. That should be there. Turn timer. There. Okay. So the comp turn timer is equal to pygame.time.get ticks. If comp turn timer minus turn timer is greater than or equal to 2000 2 seconds, row X row Y will be equal to self.moves first position. Okay, then we will have our token list tokens dot append tokens. Okay, the image will be our explosion explosion. No. Will be of a red token. So we're basically loading in our token, our hit token, like normal. Row X, row Y is the position, everything's correct there. Then game logic, row X, row Y will be equal to T because it's now going to hit. Self.moves dot remove, so we want to remove this item from the list because we've used it now. So we want to make our self.moves list less or shorter. Then we're going to say our self.turn will be equal to false. False. And then below that, return self.turn. Okay. So that's the method for our hard computer. So what's going to happen is he's going to randomly select a cell or a square anywhere in the game grid, and if it's a hit, he will then go and generate a list of all the blocks or cells that are next to that particular ship cell, or that are linked to that cell, that are all shipped. So they're all linked to ships. So, and that's where we're going to use a recursive method or function. So here under my make attack function method, I'm going to define a new method. We're going to call it GenerateMoves. Okay, and the GenerateMoves method, we're going to pass to it the self. We're going to pass it the coordinates. We're going to pass to it a grid, and we're going to pass to it a default value argument. We're going to call it last direction, which is going to be equal to none. Okay. So in our GenerateMoves method, we are going to first we're going to assign X and Y from our coordinates. And then we're going to create two new variables. We're going to call them new X and new Y. And they are going to be basically just 0, 0. All right. So the first block of the code in this thing, we're going to go with a for loop for direction in north, south, east, and west. North, south, east, and west. If direction is equal to north and the last direction does not equal north. Okay. Our new X is going to be equal to the X minus 1. So remember, up is in a negative direction, right? And our new Y will still be Y. Okay. Then we're going to say if not nx is greater than 9, or ny is greater than 9, or nx is less than 0, or ny is less than 0. Right? So that's basically make sure that the nx is still within the game grid, within the grid. If nx, ny not already in the self.moves list, and grid nx ny is equal to O. Okay, so now we're doing another check to make sure that the nx ny position is not already in my self.moves list. And then we're also checking that it is a ship position. If it is a ship position, we're going to say self.moves dot append nx ny. Remember the double parentheses there. And then we're going to call the self.generateMoves method again. And then we're going to pass it the new x and the new y position. And we're going to pass it the same grid that we've just used. And then the last direction, if we want to use, we're going to put in is south. The reason why we wanted that is, picture the square. There's 4 squares surrounding it. So you've got your square, then you've got north, south, east, west, or east, west, right? Once you've moved north, you don't want the function to check south again. So otherwise it'll check south, and then it'll see that there's a ship there, and then it'll check north again, it'll see that, and then it'll check south, and it'll see there's a ship there, and it will just up and down, up and down, up and down, up and down, and you'll end up with a Stack Overflow, because it will constantly refer to itself in like a never-ending loop. We don't want that, so that's why I've included last direction. And that's why when we wrote this function for direction, and then the first thing we checked was if the direction is equal to north, and the last direction is not equal to north. So basically, if I'm heading downwards, I don't want to check the cells above me again. All right. And then the other check that we've got is to make sure that the NXY position is not already in my moves list. There is another way we could have done this. We could have added our spells into the moves list, and then we could have just re-looped through our moves list to make sure to check if there's anything linked up with it. And that's how you would use a for loop, I would imagine. Yeah, that's how you would use a for loop. Your list of cells that are linked, that are adjacent to your ship cell, your hit cell, would ultimately grow with all the cells around it. So that list, and you would loop through it, and every time you loop through it, that list grows a little bit longer. So your loop list will grow as it's going along until it reaches the point where there's no more cells being added to that list. Yeah, that's how you would do it as an attribute. Okay, that's very interesting. Anyway, and then we're going to go, so that's for dealing with north. I'm just going to go ahead, I'm going to quickly copy this block of code, and I'm going to paste it down 3 more times. So that would be south, east, and west. All right. So we're going to go ahead and we're check. So into here we're just going to change. So if the direction would then be south, and the last direction would also be south. And then my NX would be +1. Right. And then over here we would say north. Then if the direction we were looking at now was east, and the last direction we changed to say east, not northeast, east. Okay, then we would have ny +1. My nx would remain 0, just to x, and then the last direction, in the recursive function, we would say west. Okay, and then the last one, if we were checking the cells to the west, the last direction was west. This would be -1, nothing. And then here we would say east. Alright, so that would handle our recursive function. Then we would just basically return because we're dealing with our self.moves list. Alright, so we have the GenerateMoves method built for our hard computer. We basically have our hard computer class selected, created. Now we need to be able to choose between the 2 computers. Choose easy or choose hard. At the bottom here, I was thinking the best way to go ahead and do this is in our event handler for buttons, where we call the buttons. If button.name is equal to easy computer or button.name is equal to hard computer, button.active is equal to true, game step and stage one. I was thinking over here, we would say if button.name is equal to easy computer, right? Then our computer variable would be equal to the easy computer. If button.name is equal to hard computer, computer would therefore then become the hard computer. All right, let's give it a crack. Let's give it a go and see how we come along. So we're running our game. The game is running. We're in the main game. I want to try the hard computer. Let's play against the hard. Let's randomize our positions. The ships are on the board. Let's deploy. Let's go. So what we're looking for is to make sure that if the computer hits our ship, when the computer hits our ship, the very next move of the computer should be a cell ultimately right next to it. Okay, fantastic. So the computer has randomly selected and it has hit our battleship. So the way we wrote the recursive function, is it's first going to check all the blocks to the north of it. Once it's checked all the blocks to the north of it, it will then check all the blocks to the south of it, which it won't, so it'll go up. What I'm expecting to see is the computer now select this block here, and then the computer should select this block here, and then the computer should select this block here. I believe the computer then should return back and select this block here, then this block here, then this block, and then upwards. So let's test my hypothesis. We crash to desktop, which means row X referenced before assignment, line 398. That's interesting. Let's go up to line 398 in my hard computer class. And my make attack 398, line 398. If len.self-moves is greater than or equal to 0, we've got row X, we've got a row Y there. Oh wait, these are supposed to be there. Yeah, they should have been under this if block. If check here. Okay, let's try this one more time. So we want to play against the hard computer. Update screen, game state. Really? Line 51, line 908. Line 908. Line 908, ship.select ship and move. Oh goodness. Okay, line 51. In my ship class, I remember when we were moving ships around, then it creates its own little game update. Select ship and move. Update game screen. Got game screen and game state. Right, silly little error. My apologies. Let's try this one more time. Hard computer. There we go. Let's just do it like that. I think it would be interesting if we do those movements. Like that. Alright, let's put him there. There. So basically we want our ships all to be connected at some point. Somehow. Okay. Deploy. Miss. Computer player. Makes a miss. We make a hit. Computer player will now make a miss. Oh, is he going to miss all day long? Come now, computer. Oh, goodness, another miss. Oh, my word. This is going to be hilarious. It's going to take forever for the computer to hit one of our ships, isn't it? Oh no, let's see how far I can go before he makes a hit. Ideally, what will happen now is once the computer's made a hit, because all these ships are touching each other, the computer should then just ultimately hit all of these ships. And as soon as the computer decides to make a hit, oh my word, I'm unlucky. I'm going to run the radar scanner because I want to. Maybe I can still win this out. There we go. The computer's thinking, and he made a miss. My turn. Computer's turn. Oh, he made a hit. There we go. What we're expecting to see now is the very next one to be north, 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 right, 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 south, 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 right, right. That's what we're expecting to see now, actually. The next hit, north. Next hit should be north. Next one should be north. Next one should be north. Next one should be north. Should now be to the east. It should now be to the east. Should now be to the east. Should now be to the south. Should now be to the south. Should be to the south one more time. Should now be to the east again. One more time to the east. Alright, and then what I'm expecting, it should come all the way back and it should be over here. This should be the next ship that it hits. There we go. That's how the function's working. That's how we wrote it in Recursion. And how it's adding those each ship hit to the moves list. Remember, we'll go all the way to the edge and we'll go up again. Okay. Last one. And now it should hit the south. And go west. Well, there we go. Computer makes the last hit. And we get pushed to the in-game screen. We have the option to quit. We can play the easy computer again, or we can play against the hard computer. Let's go for the easy computer. If we click it, what happens? Nothing, because we haven't. Okay. That's the last thing we need to input quickly. Where's that? What's that? Let's go back to the bottom here. Buttons. If button dot name is easy computer, hard computer. Okay. We basically need to restart the game whenever we call that in. We've got a function that says restart game. We should have a function that just restarts the game. Display, random ship deployment phase, randomize ship position, sort fleet. Or is that in the button itself? Where's the buttons? Button. Restart the game. Tokens.clear. Well, we can still run those. Okay, so if we can just do it either way. So open is either computer or hard computer. Doesn't matter which one of those two. We're going to go with so the tokens list must be cleared. Tokens not clear. Wait, did we copy and paste it? No, we didn't. Oh, let me just remove that out of here. Tokens not clear. We want to clear the tokens from the screen. What's the other thing we want to do? Update. Wait, I'm going to reset the reset. What is it? Randomize ship positions. Randomize ship positions. And reset. So I've got reset ships. Reset ships. So then we go for ship list. So we want to reset ship list for ship and player fleet ship.rechange default positions, randomized ship positions. That's going to be computer fleet and computer game grid. And then last one we're going to call an update game logic. That will be the player game grid, player fleet, player fleet, player game grid, player fleet, and player game logic. And we'll call the same thing one more time. Game logic for the computer, fleet, computer game logic. Sorry, my nose is itching. That's annoying. Right, and the last thing we want to do is a deployment status be equal to deployment phase plus deployment, and then deployment equal to status. That is only if game state is equal to game over. For that one there. Alright, there we go. What have we got from now? There, that must be is equal to. Alright, let's just try this all again quickly. Okay, we've still got our cheats in the bottom right, so let's play with a hard computer. Randomize deploy, remember our little cheat sheet, middle mouse button calls the grid for us so we can see what's going on. So that's a hit. 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 That one. 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 I wonder if we can get all of their hits before they even hit one of mine. That would be cool. Ah. What a pity. Damn. Okay, where are we now? That one. That one. That one. That one. That one. And this should be the end of the game. Game over. Alright, now the game should restart. So if I hit the easy computer, randomize, deploy. That's the location of the button. I wonder now. I should actually put this if game state is equal to game over. I can put it there. Alright. And all of this logic here should be falling under that if check, as well as this logic here. Remove the game state back to stage 1. But another button is still there. Why is the button still there? Button should not still be there. Okay, so in my deployment screen, the buttons, those ones, button actions, it's true, else button it's false. My end screen. Let's go to hard computer, randomize, deploy. Thinking. Okay, it's working perfectly fine. I just want to see where's the ships, where's the ship that I can attack. There we go. Just going to put it out quickly. We've got a bunch of ships there. Take a long time. I just want to check the end screen. There seems to be a button in the way. Okay. Alright, see, here's my easy computer button. Here, it's these cells here. Oh, so my computer goes first. See, here's a problem. It's still picking up that button there. Why is that button still there? That button should not still be there. move. Wait, why does the computer make a move? Alright, now I can make it. Of course. I can't choose that. What's going on there? That's what's going wrong. We're not cleaning the grid. The grid's not being cleaned. That's the problem. That's the first issue that's going on. I thought we were updating the game grid. I thought we updated the game grid. Did we not? I thought we did. Update game logic. Computer game grid. Computer game logic. Let me go to my update game grid function. Update game grid function. Update game grid function. Update game logic. Update game logic. Yeah, update game logic. No, that's right. Update game logic. Right. So what's happening is it's going through and it's keeping the old positions because it's not clearing the list first. So I think what we need to do Pygame logic equal to create game logic rows and columns. And then C game logic create game logic rows and calls. Okay, I'm just quickly going to, I want to test it one more time, which means I'm just want to, on the computer, play it turns, that little time delay. I just want to take that off while we're testing this, because it does add extra time that we don't really need. So that time delay for the make attack, I'm just going to make it 10 for now. Just wanted to play against the easy computer. Alright, easy computer, randomize, deploy. Okay, so we can basically move along very quickly. Radar scanner there. Okay, let's just print out. Okay, so there's a couple ships over there, positions. There's a little ship. Right, we have, oh, there's a straight up line there. 1, 2, 3, 4, 5, 6, 7. There we go. And then if we hit the easy computer, we have a new game on the way. Randomize our ship positions, deploy. If we print out the game grid one more time, it's a new grid. There's a new grid in town. There's a new grid in town. Sounds game sounds. We need to add sounds quickly and then we're done. Okay, sounds. So down here in our, where are we now? Loading game sounds and images. Right at the bottom of that, we're going to load hit sound. That's going to be equal to Pygame dot sound. No, Pygame dot mixer dot. Does it sound? No, hang on. It's going to be, okay, so that's what it is. It's Pygame dot mixer dot sound. And then we're going to be loading assets, sounds, explosion dot wav. Okay. Hit sound dot volume set volume. It's going to be equal to 0.05. Or too loud. Shot sound will be equal to Pygame dot mixer dot sound. Assets, images, assets, sounds. Come on, sounds. Gunshot dot wav. Okay, and then shot sound dot set volume 0.05. Okay, last one is miss sound is equal to Pygame dot mixer dot sound. Assets, sounds, splash dot wav. Then miss sound is equal to set volume 0.05. Alright, that is straightforward. Miss sound dot set volume. Okay. So we have a hit sound, shot sound, and a miss sound. So let's go up to our make attack firstly. For the player, make attack, we're still printing this hit out, we can get rid of that. We're printing out the miss, we can get rid of that. We're going to play shot sound dot play. Right. No, hang on. Yes, shot sound dot play. Miss sound dot play. If it's a miss. Alright. If it's a hit, we're going to go with shot sound dot play and then hit sound dot play. Okay, let's just open up. This might blow some of our ears off, so just be prepared. Easy computer, randomize, deploy. This is the game grid. There. It's working. Now we just need to include the computer player. Okay, so for the easy computer, we're just going to copy that. For the computer player, if it's a hit, put it there. For the hard computer player, we're going to do the same thing. If there's a hit, put it there. Same, just slightly below it, put it there. Go back 3000, easy computer, 3000. Alright, and then if there's a miss, if it's a miss, we need to include the miss sound, shot sound, miss. just need to put it there. And for the hard completer player, sound hit, sound up play. We'll put it over there. Shot sound. Straightforward, included methods. Okay, let's have a look quickly what's going on here. Let's take a look. So our game, we're going to play against the hard computer. Randomize our ship listing, let's deploy. Let's do the radar scanner first up. See how it's going. There's a hit. Good job. You got my submarine. That was a miss. Got my submarine. I got a hit. You got a hit. Ish. Oh dear, there was those 3 ships. Well, computer player is currently winning. Let's just check the radar one more time. Position. As you can see, we're not faring too well against the computer player. I'm actually concerned I'm probably going to lose this round. Sounds like we're going to lose this round. It looks like we're going to lose. I wonder if I'm going to make it. I wonder. Yes, I cheated. I got cheated. I know. But then because I want the round to end, I want to thank you guys for following through with watching this video series, and I hope you learned something through out of all of this, and I hope you had fun. I hope you made the game yourself, and you enjoyed it. And I'll see you in the next series. Bye for now.